Okay, this is 27A. And it says, we're now moving into absolute extrema, whatever that means. It said if a function has an absolute maximum at x equal b, then f of b is the largest value that f can attain. Similarly, if a function has an absolute minimum at x equal b, then f of b is the smallest value that f can attain. So if I look at the graph, absolute means absolutely the biggest in a region. So that says if I were to just look at the valley and I say, okay, I don't want to look any place outside of the valley. So the valley I'm restricted to. I want to know what the absolute highest point is in the valley and the absolute lowest point in the valley. There's going to be a lot of high points, but I want the highest of all the high points, only in the valley. Right? If I move outside of the valley and include Flagstaff, is there going to be something higher in Flag than there is here? Yeah, but I'm not worried about that. I'm only worried about in this little region right here, what's the highest, what's the lowest. So when you talk about absolutes, absolutes means that in that area that I'm looking at, I want the biggest number and I want the smallest number. Now this is the one thing you have to worry about or watch out for. If I'm looking at relative max, relative min, and here's an absolute relative max, these guys right here, this comes from where f prime equals 0. It's the result of the derivative. Derivatives give me relatives. Derivatives give me relatives. It might also give me an absolute, but it gives me relatives. It says, these are my potentials. What makes the difference? If I'm looking at the region, then it says if I'm only going between A and B and E, that's my restriction. The absolute can happen either at the end of my region, like this guy, or within the region, like this one. Here the end, well, this is small, but it's not as small as this end, and it's not as small as this relative min. So the question you would ask yourself, what do you do? Anytime I see the word find the absolute, I set up a T-bar chart. In my T-bar chart, I put my endpoints. In this case, it's A and E. So those are the endpoints. Then I take the derivative, set it equal to 0. Then I put in my maxes and mins as a result of the derivative. That's my humps and my hills and my valleys. So that would be, in this case, B, C, and D. These guys are the result of F prime. And these two here are endpoints. So that as I look at the situation, absolute occurs either at an endpoint or hill and valley within the interval. Then I calculate out my y values. And this guy here, if I look at A for my picture, this is the smallest. B is a max. C is a min. D is the biggest. And E is a min. I look down my list. I pick the smallest y value. That's the absolute min. and I pick the biggest y value, that's the absolute max. It's gotten from a T-bar chart. So the minute somebody says find the absolute max, find the absolute min, I first put in my endpoints. My endpoints, by the way, could be minus infinity, infinity. That means I'll be taking limits. Right. And so at which point, here it's A and E, then I take the derivative, set it equal to 0, put in my critical numbers of max mins, then essentially calculate out the y values. The biggest y value is the absolute max in this list, and it could be an endpoint. Smallest y value is the absolute min.
Question.
Yes?
Would the end behavior of a function be able to tell you something about what you'd be able to find, like as far as absolute value?
Yes.
Max or min?
If you take a look at something like absolute value, it has no absolute max.
Or I meant to say the absolute max or min. What I meant to say.
End behavior could, except if it's going from minus infinity to infinity. But if I'm going in an interval, that's not going to be the case.
Right, okay.
So if I'm going to go through an interval, that's not going to necessarily be the case. Because the interval, as you can see, this guy continues to go down. So is there something smaller than this value? The answer is yes.
Right.
But it's just not included in my world.
Your interval, yeah.
Yeah, not in my world. Now, taking a look at this graph. Use the graph to state the absolute and local maximum and minimum values of the function. Local, by the way, local comes from f prime. That means a derivative has to exist. So locals are hills and valleys. Now, if I take a look at this first guy, this graph comes up and then comes back down. Now, is 1 a local max or min? No. There's a hole here. So he doesn't count. It doesn't exist at that value. Right? You can't set a horizontal tangent on something that doesn't exist. There's a hole there. So he doesn't count. Then I come down and I notice he is a min, and the minimum, and let's see, I'm trying to figure out, this is 1. This is, looks like it's 2. So it certainly is a local min at x equal 2. And then he continues on in a nice graph here, 2, 3, 4. There is a local max at x equal 4. Then he continues on and he creates a bird. Remember, that's that vertical tangent thing. That's when you take the derivative, that the function moves to the denominator. It didn't have a VA to begin with, but then it doesn't exist when you take the first derivative. That guy moves to the bottom, creates that little pointy thing. It is a minimum, because that's where f prime does not exist. And that is at 5. So these are locations of local maxes and mins. This would come from f prime. So take the derivative, set it equal to 0. You'd have domain exclusions at 1 because of the hole. You have a problem here because there's a jump discontinuity. So then I look at what else do I have to take into account. here's an end point, and here's an end point. The problem is this end point is an open hole. So that if I'm going to try to look at absolute maxes and mins, what's the biggest? Well, the biggest that this guy gets is this guy. And now again, if these are all ones, let's see, I've got to find 0. 0, 1, 2, 3, 4. This guy looks like it's 5. Absolute maximum min is a y value, so it's at 5. So that's the highest this graph gets. What's the lowest this graph gets? Ah, but does it? I got to mark the x-y axis here, because otherwise I screw myself up. It's a hole. So do I have an absolute minimum? No. None. And that's because I have a hole.
It wouldn't be 2?
No, because this is an endpoint. And this endpoint is at 1. So if it were a solid dot, you'd have an absolute minimum at 1. But you don't, it's an open dot. And then you can say, well, y doesn't have 1. Well, you give me a y value, and I subtract 1 from that y value, or subtract 0.00001 from that y value, or subtract a million zeros and a 1 from that y value you give me, it's still smaller than your y value. It never gets to 1, but it gets very, very close to it. It just keeps going forever and ever and ever.
So the reason why you can't have 2 is because one would be the answer.
1 would be the answer because it's the lowest. And that's a damn hole. Whoop, I'm videoing. I should have said that. I am now in trouble.
So x equals 2 isn't the absolute minimum because the endpoint goes
Is lower.
than that?
Yes.
Okay, sorry.
Yeah, and see, here's 2, and there are still y values that are below, and this is 2. There are still y values that are below 2, so it can't be the lowest. However, it is a relative minimum. It just is not the absolute minimum. And I know that's picky, and we're not going to run into that many picky things, but I wanted to kind of bring that in. If you have a hole there, that's going to be an issue.